Okay, thank you all guys for hanging with us here. It's this is Nico from Ambient.
Hi, I'm Nico. I'm the international sales manager from Ambient Recording in Munich, and this is Yannic.
Thank you so much, Nico. I'm Yannic. I'm doing a lot of marketing, but also involved in the product development. Ambient is a small manufacturer from Munich. We're producing and manufacturing everything there. We're mainly known for our Timecode products and boom poles. And today, I'm glad so many people showed up because we want to talk about a very nerdy, a very niche-y topic, timecode and sync. But still, a lot of people are interested, and yeah, let's see. We have some demos prepared for you, but we'll start with a little theory. Yeah, it doesn't help. Timecode can be a complicated topic, so we have to start with a little theory. I'll take over from here, Nico.
Okay.
All right. Yeah, let's start the presentation. Timecode and synchronization. Nico, you can have a seat. It's okay. It's okay. It's okay. No problem. The first question we have to ask ourselves is, what is it good for? Why do we need timecode at all? And to know why this is so beneficial for post-production, for the whole production, we have to look at it from the post. If you're shooting with more than one camera on a set, if you're recording audio separately, if you have a multi-camera shoot, if you're using timecode generators to synchronize all the cameras on the set, all you have to do in post-production is basically click one button. Well, you will see later it's actually more than one button, it's a few buttons, but it will save you a lot of time when aligning all the material. Or in other words, this is how an editor looks like if he has to crawl material that is where no timecode generator was used on set. It's really like searching his ass off for the slate or the clapper sticks, or like here if they forgot to record the slate at all. So basically, without timecode on set, it's really a manual search for sync points. It's either a slate or some audio peaks or stuff like that. So it's a lot easier if you take care of that already on set. Actually, what you do with this timecode generators is that you on set are already preparing the post-production and saving a lot of time there. This is how this looks like. In brief, we will go into that in detail later, but basically this would be like a 3-camera shot, and you click synchronize by timecode, and clack, it gets aligned, and you can start editing. This is how it looks like in Premiere Pro. In Avid, for example, it's a little bit different. You click different buttons, but basically it's the same thing. You're using timecode, the timecode of the clips to align the clips in the post-production. So now that we know timecode is basically there to save time in post-production. There's the first problem, of course, because the people on set, they don't have any advantage of timecode. Yeah, that's always the fight between the post-production and the camera department, because the camera department, of course, wants to get rid of anything additional that sticks to the camera. And if you have no advantage of it on the set, it's even harder for them to convince. But actually, by using those timecode generators, you help your colleagues in post-production a lot. But now, let's look a little bit in the history of time. How did timecode came up? Why do we need all of that? Actually, the need for something like a reference point in editing, it really goes far back in time when they were shooting on celluloid still. I mean, if the editors back then made their cuts with the positive material, they did manual notes on the material and to kind of align them later. So this is kind of the first step of timecode, and later Kodak invented something automatic on that. They had some edge numbers that were really printed on every frame of the film material. But that is far back then, and then in the 60s, the video came into place, and there was even more need of timecode. And then the SMPTE, this is an association for filmmaking. They decided to go, okay, let's choose one standard for timecode, and now let's look at a little video on how the timecode evolved then.
Timecode was defined by SMPTE in 1967. The goal was to create a set-spanning reference for multi-system workflows that includes multi-camera shots and separate picture and audio sources. When done properly, Timecode workflow replaces the time-consuming task of manual alignment with precision, automatic alignment, executed with the click of a mouse. The idea is fairly simple. Each frame gets a unique number. You could compare it to an individual postal address so that everybody in post-production can find that particular frame just by referencing the timecode. When this reference is simultaneously recorded on all devices, all corresponding frames get the same address. Even though there is only one SMPTE timecode, it can be stored in different ways. When tape was the standard, it was stored as vertical interval timecode, or VITC. As most cameras manufactured today store file-based clips, timecode is stored as metadata in the video file. And now, the audio world. In today's professional workflow, the timecode reference in modern production audio recorders is also stored as metadata, but in broadcast WAV files. Yet it is still distributed as longitudinal timecode, or LTC, as it was when tape was the standard.
So the basic idea is really of giving each frame that is recorded a unique address so that it can be uniquely be identified in post-production. This is the basic idea of timecode. So again, each frame gets a timecode, and the same applies for audio recordings as well. As said, back then there was like when you were shooting on the tape, in the tape area, the timecode was again placed on the top of the material, but today it's stored in metadata. I mean, everyone who has ever ingested something to an editing tool knows that the timecode is integrated in the file today. And then there is LTC. This is also some devices like, for example, the sound devices Scorpio or other professional sound recorders. They of course can also be synced to timecode. They also store it in the metadata. There is a little special when it comes to cameras and sound recorders that do not have a professional timecode input. I mean, this here, he has on the Scorpio, there is a TC in. On this kind of Sony rebuild, there is a TC in back on here. But if you, for example, grab a DSLR like this Blackmagic rip-off, there is no professional timecode in. Or if later we are showing this with the Sony Alpha 7, in this case, there is the possibility to ingest the timecode via an audio track. This LTC, the longitudinal timecode, it's really like it's really like a sound file. So it has a sound. You can listen to timecode actually. It sounds like that. Sorry, I can't stop anymore. Okay. Sounds great, doesn't it? And so in this case, the timecode information is actually recorded on one of the audio tracks in some noisy sound, and later the post-production tools, then they can convert this audio signal into real timecode metadata. This works like this. If you're looking at the timecodes here, they are random something, and then there is a feature, for example, in DaVinci where you say update timecode from audio track, and then it kind of replaces the native timecode from the camera with the good timecode from the log hits. So those are the both ways of doing timecode game. However, it's of course even always the better solution to have a camera with a professional timecode in if you really have a multi-camera shoot. But often DSLRs and other cameras are in use, so you have this workaround. So now timecode evolved back then when studio was still a big thing and most feature films were shot in studio environments. And timecode back then was kind of cabled to a studio master clock. It was kind of in a rack, and it was a big master clock, and cables went around to all the cameras and hardwired those cameras to run on the same timecode, which works perfectly fine, but only in a studio situation. And as time flies now, since many, many years, the people went outside. They shot on location. They are going in the desert, they're going in the forest, and they want to shoot the stuff where it happens. So there was the need of a portable timecode generator, a portable version of this studio master clock, and that's what our CEO, this is Günther, with a very old school photo here, but this is Günther, still the CEO of Ambient. He invented the portable timecode generator back then. It's been a long time. 1993 was the first locket that hit the market. I mean, we served many types of cameras. We served from tape to now digital. The lockets back then had many different colors and stuff like that. Today we are in the blue version. It's already the 8th iteration of the lockets. What all of the devices have in common is their unrivaled accuracy. All those devices actually have a highly accurate clock inside. That's basically the magic. Those devices, if you match them up, then they won't drift during a day. Less than a frame. That's 0.1 pulse per minute. It's really the highest accurate clock you can find in this purpose. And now I want to give you some tips, like these are kind of frequently asked questions or the most common misunderstandings and stuff like that when it comes to timecode. We kind of stuffed that into 5 golden rules, as to say how to handle timecode. Are there any questions so far? That's fine. That's cool. Okay, now. Let's start with the rule number 1. The locket stays on camera. It's a common misunderstanding that it's okay to kind of jam the camera or the audio recorder once a day with a locket device and then plug it off again and you're good to go. It's not. Because it doesn't prevent the problem. The problem is that the cameras, they have bad clocks inside. They are not accurate and they drift to each other. So you need to have the locket box, the timecode generator, to be attached to the device all the time, the whole day. There is no, sorry, camera department, there is no way to rip it off during the day, because then the devices will start to drift again. So that's kind of a prerequisite to have it all running. They have to stay on camera all the time. This is why we provide our lockets with some nice little stickers. They are kind of aimed for the camera department to convince them to keep the cameras there in different emotions, depending on the personality of the camera person, of course. Then there is the second important thing. The camera is always right. And what I mean by that is there is no way that you can kind of force the camera to take over a different frame rate with a timecode generator. So if you want to shoot on 25 frames, but the camera is set to 30 frames, it's not enough to kind of set the frame rate stuff just on the locket, plug it to the camera, and think you're good to go. No, you have to do all your set, all the cameras. You have to go into the menu and say, okay, 25 frames, and the locket, of course, as well. Otherwise, there can be issues. So that's important to know, that you cannot externally force the camera to take over another frame rate. And while talking about frame rate, there is another important rule. You shall only have 1 frame rate in your shooting. I mean, I hear some people laughing because obviously this is something that sometimes happens if you have multiple units and stuff like that, or you have to combine material from different sources. It's always a pain if they are shot on a different frame rate. The problem is that if you start the editing and if you create a timeline, you have to decide for one frame rate, of course. And if you have a 25 frames timeline and ingest a 30 frames video in there, it is a slightly slow. That's a little slow-mo thing then. So this doesn't work. So this has nothing specifically to do with timecode generators, but this is a general tip. Please, if you do whatever shooting you do, speak to all departments, be it editing, sound, cameras, to kind of decide, choose one frame rate. In the camera menus, you always have to be a little bit careful about that because there is something that is called project frame rate and something that is called sensor frame rate, or sometimes they call it different. But basically the project frame rate or project time base, this is on the lower end, you see like how it's done in for the red cameras. This is what I told you. This is the common frame rate everyone wants to shoot on. This is the frame rate in which the playback on the camera is running. This is the timeline of the editing then. The sensor FPS can, however, be different if you want to do slow-mo, for example. So you would just put the sensor FPS to like whatever, 100 frames. But keep, of course, the project FPS to 25 to not get mixed up there. And now, when we're talking about frame rates, there's always the question, which one to choose? Because the camera menu and also the editing timelines, they offer you different frame rates, as you can see it here. I mean, if you have, in Europe, basically, if you have nothing, if you don't have any other reasons to do something in a specific way, it's always a good idea to do it in 25 frames. That's the common standard here in Germany. However, there can be reasons to do it differently. And about the whole frame rate thing, we watch another video.
This topic can be confusing, as it often confuses professionals that use it every day. The world is separated into two different timecode areas: the European-influenced PAL area and the American-influenced NTSC area. In regions of the world where PAL is used, television productions run timecode at the speed of 25 frames per second, and feature film productions at 24 frames per second. In areas of the world using the NTSC standard, television productions run timecode at 24 frames, or most commonly 30 frames, but at the time interval of 1 second plus 1 millisecond. That's 1/10 of 1% slower than the European PAL standard. As broadcast companies require reference to conform NTSC television frame rates to real-time, SMPTE came up with different solutions. The first solution is to incorporate drop frame rates, which omit select frames to approximate a standard 1-second time reference. So when using 29.97 drop, 2 frames are dropped every minute, except every 10th minute. This caused a lot of confusion and problems during post-production, as a changing time constant makes it impossible to conform drop to non-drop timecode. With the second and most widely accepted solution defined by SMPTE, production cameras, audio recorders, and timecode generators operate at the speed of 23.976 or 29.97 frames per second to capture 24 or 30 frames while maintaining the NTSC standard. For example, when shooting in the NTSC area at 30 frames, you're actually shooting at 29.97. So if you switch the audio recorder to 29.97 frames per second, they will align perfectly in post and everyone will be happy. And don't use drop frame rates if you can avoid it. Beware, if you are shooting in Europe or you want to shoot a 24 frames per second feature film production on a television cam, make sure the camera is set to PAL. Otherwise, the displayed 24 frames could actually be a 23.976 frame rate. In any case, you should carefully read the camera manual.
It's always good to read the camera manual anyway. But to kind of maybe this sounded a bit complicated, but there are only 3 basic frame rates. Okay, this is the 24 frames that we know from celluloid. This is the cinematic standard still. Then we have television standards for the PAL region and the NTSC region. Actually, 25 and 30 they derive because they had to television back then was only broadcasted live, and they had to synchronize with the power grid. In Europe, the power grid runs on 50 hertz, and in the States, it runs on 60 hertz. So that's how those frame rates occurred. Actually. That's that, and an often question, because I see it here, there are no double frame rates yet specified by SMPTE, because like in The Hobbit or other examples, directors start to want to use maybe like shoot the whole thing in 60 frames or 48 frames to get some kind of smoother movements and stuff like that. There are specific reasons to do that. This is not yet specified, however, you can already do it. You just pick the half of that. So the higher frame rates always double some standard frame rates. So in the camera menu, then you would or in the lock-it settings and in the camera menu, you can stick with the 3 basic frame rates. Back to this NTSC thing. The NTSC guys, they also think in 24 and 30 frame rates. However, in our world, it's 23.976 because they are a little bit slower. The reason for that is this guy, Guillermo González Camarena, he invented the color TV back then. And for some reasons, the NTSC engineers found it a good idea to place the color information within every second. So they took a little bit of every second and placed the color information there. That's why they are a little bit slower and causing so much problems these days, even though no one's watching TV anymore. But still, yeah, I mean, still this is the standard. And again, this drop frame thing, just don't do it, okay? Long story short, just don't do it. It does not make any sense. If you see it, run. Then there is the topic where it gets a little bit more complicated because timecode is not the same as what we call synchronization. Yeah. To get us started in this topic, I have another short video for you, and then we go into detail here.
Timecode is not synchronization. To explain the difference between the two, we can take a look at the following example. In this scenario, there's an audio recorder sending hardwired timecode to 3 cameras recording a concert. The timecode is perfectly constant, as all cameras receive hardwired timecode from the audio recorder. However, when the editor plays back the material after initial alignment in post, the material gradually loses sync and gets worse as playback continues. How can this be, as all units have a hardwired timecode connection? We have to look at the individual devices to understand the problem. Each device and its internal components operates at a unique speed determined by its internal processor clock. So within a camera, its internal processor clock determines the speed of the shutter, the video processing, and the A to D converter controlling its internal audio tracks. And each device's internal clock has a different level of accuracy, so even if you begin recording at precisely the same moment, the recordings captured at different clock speeds will gradually lose sync with each other beyond the first moment that they are played back in post. At this point, one might still ask, why doesn't the constant timecode prevent this problem? As we are using modern, file-based production audio and video recorders, the timecode is simply a documented stamp referencing the beginning and the end of the recording. As the timecode is controlled by the audio recorder's clock, the audio files and timecode are in perfect sync. But the cameras are all running at different speeds. so the captured material and the timecode are at different speeds. In other words, the position of the material does not match with the timecode. This is called drift. As the recording gets longer, the drift gets worse. But in situations with only short takes like most feature films, drift rarely presents a problem. When shooting events or documentary-style productions, it often produces headaches that can easily be avoided. SMPTE defines certain synchronization formats to deal with this issue to enable multiple devices to run at the same speed as a master clock source. So the slave devices run at precisely the same speed as the master clock. So let's take a look at different sync formats. The video sync format is called GenLock. Basically, it's an impulse generated per video line and is specified by video resolution and frame rate. These specifications include PAL, NTSC, HD 720 and 1080p, PSF, or interlaced. Anything beyond that is unspecified, such as 48 frames per second used in The Hobbit. In the audio world, the sync format is called word clock and is specified by sample rate. So how do we solve the sync issue in our example? The material will sync when we control the clock speeds of the individual devices. There are two ways we can accomplish this. With the central house clock and the OB van with the GenLock sync and word clock outputs hardwired to all devices. Or portable, high-accuracy clock units with GenLock sync output connected to each camera, with word clock available for the audio recorder depending on the accuracy of its internal clock.
So again, long story short, if you only feed timecode into cameras on the set, those cameras will, when they start recording, they will have this accuracy, they will be in line and stuff like that. That's all fine. So you can kind of align them in post-production, as I showed you before in this little clip. So this works perfectly well with timecode, and there is no issue when you have in a regular feature film where you have like shots that are like 4 to 5 minutes or stuff like that. But I don't know if you have ever shot kind of an event that is really like an hour or half an hour or longer and stuff like that, and you have timecode and everything is nice and fine in the beginning, but you have it in the timeline, and in the beginning it's right, and in the end, after an hour, it's not lip sync anymore. And you go crazy and you say, what's the problem, man? But the problem is that from, as said, the timecode only references the beginning of the clip. And from then on, the cameras run at their own processor speed. Yeah, this is, and the solution here is to kind of really hard control the processor speed. By using our lock kits that our lock kits have both. They have the timecode signal, of course, but they also provide this sync output to really hardly control the processor speed of each camera. So they're really telling the camera at which speed they should write the pixels. Yeah? So it's really, they are telling the camera, now, you do it now, and all the cameras. So they're doing everything in sync. They're really controlling this speed. And that's why on many cameras you probably have seen already that there are 2 inputs. Maybe we can go to this top-down camera for a moment. As we can see it here in our rebuild of the Sony, they have two inputs actually. The one is for the timecode, as said. It's just the information at which frame rate are we, and what's the timecode of this specific frame that we start. And then there is the second input, the GenLock, where we really hardly control the speed of the processor. If you see like this like magic thing again, there is no possibility to kind of do a GenLock input here, right? So if you're really shooting an event where the takes are longer than 20 minutes, let's say, or planned sequences or stuff like that, you should really avoid using cameras that have no specific Genlock input. But the camera manufacturers know that the problem exists. That's why the more professional cameras, they have this Genlock in to let them to give the people the possibility to externally control the speed of the processor. Okay, we can go back to the presentation. Thank you. So, as said, there is in the audio world where this sync signal is called word clock. It's specified by the sample rate, be it 40A or 96 or whatever. You can adjust it in the menu. And in the video world, it's called Genlock. The most commonly used Genlock sync format is tri-level sync. This is specified if it's PAL or NTC. Which resolution are you shooting? Are you shooting interlaced or progressive? This is the stuff you have to do that. Exactly what's said in the video, you should read the camera manual in this case, because not any camera accepts every sync formats. You have to really double check it there. Yeah, that was that. Do you have questions on this timecode versus synchronization thing, where the difference lies? That's good. That's very good. So actually, again, we have in our Lockit family, we have our classic Lockit with these two outputs. It's timecode and sync output, but we have also a smaller version that has only the timecode output. The reason is because in many cases timecode is enough, as said. Yeah, if you have clips that are no longer than 5 minutes, you're perfectly fine with timecode, because the camera clocks aren't that bad that they drift within like 5 minutes of operation. But everything that is longer than like 20 minutes, you should really consider to externally put ingest in an additional Genlock signal to really be sure that your material that you're using in the post-production is synced. Now the last important thing, make sure to bring the right cables, because any camera has different connectors and stuff like that. So if you're the person responsible for timecode, you really have to have a little box or whatever with many different cables, because you have to be prepared for any type of camera that can occur. So there are options, of course, here for the 3.5mm audio jack. It's BNC. There is LEMO. There is also XLR. There are many different cables. So yeah, that's why on our website we have a specific cable guide as well, where you can before shooting kind of check which cable might fit. But the cables are something you have to consider as well when talking about timecode. Another important thing about cables is to know that timecode has a direction. It's not bidirectional, it's unidirectional. So for example, here at our Scorpio, where we have a LEMO in, and our Lockit has also a LEMO connector, you wouldn't know which one to plug in where. So we have this color-coded stuff here, and also a little arrow on our cables to show. You can't see it now, but actually there's an arrow showcasing the timecode is flying from this device to that device. That's sometimes also a common mistake that can happen, that the camera is plugged in the wrong way. All right, so now that we basically know everything necessary about timecode, about synchronization, now the question is why Lockit? Why choosing the Lockit system then, since there are other timecode generators in the market as well? However, Lockits are highly trusted in the industry. We are on big sets, on small sets, and also other manufacturers like Red or Panavision. They in their big production cameras, they have our timecode module built in, so you don't have to have an external box built in there. So that just shows that this timecode, the accuracy of our clocks is really highly appreciated in the industry. This is this Locket module I was talking about, and yeah, for example, Red and for this V-Raptor XL, and also the DXL2 from Panavision, they have this module built in to please the camera people to not have an external box in there, of course. As well, there are other applications that use our Locket modules. This is, for example, an application where you have a facial recognition thing on the actor, and this has to be synced to the studio cameras that capturing the motion of the person. This is for CGI shots, and they are, for example, also using Lockets to wirelessly broadcast the timecode information, and there are many other implementations on that. But when it comes to you, why Lockets are a nice thing is because we have they communicate to each other via a thing we call ACN, Ambient Communication Network. That's why they all have these little antennas. Okay, they are communicating to each other with a very low radio network that's really resistant to any disturbance from the outside. It has a long range. It works quite good, and the reason why we do that is because we can via this we can make them automatically sync up each other during the day. So every 6 seconds, you can see it actually like here. I mean, they are flashing green in sync, and now and then the green light is flashing a little bit longer. That means they are tuning each other to the same value as well. So this really makes sure that there is zero drift. There's no drift at all. I mean, those devices would run if they wouldn't have ACN. They would drift less than a frame anyway during the day, but thanks to this whole ACN, there is no drift, no possibility of drift at all. They are always communicating to each other, making sure that our boxes run on the same timecode without any user action. It's automatic. And as you can see, we are also on TikTok, so if you want to follow us. What you can do with the great thing about this ACN is that it's easy to set up, right? So if you once you have made all your settings, you have kind of took your Locket to adjust the frame rate, for example, and the sync format and the ACN channel and stuff like that. You have to do it only once, okay? Because you should stick to the same frame rate anyway during the whole shooting. And from then on, you just have to, when you come to the set in the morning, you just have to turn on the devices. You take one of the devices and you kind of press the green button of the device you want to be the master, and it broadcasts the signal to all the other devices that are turned on. And that's it. So there is no setting, no kind of going into menus, grabbing an app, connect via Bluetooth or something. It's really just turning them on, grab one of the devices, press the green button, and you're good to go. That's the beauty of this ACN thing. And this, of course, also works for the built-in things. This is the Raptor XL. As you can see here in the menu, they have built in this module. And then you can also externally and wirelessly jam sync this camera via ACN. As said, it's very reliable, stable connection. It has a long range, and there is an unlimited amount of devices that can do this stuff. So if you have a really highly intense shooting where you have kind of a great action thing going on with 30 cameras shooting at once, it's also possible. I mean, you need a lot of Lockets, which is good for us, but it would work, okay? Okay. Then, of course, the thing is that we have a device that provides timecode and sync. This is most other manufacturers just provide timecode, as said, which is okay for most occasions. But once in a day there will be those shootings where you have longer clips, where you have maybe clips that are longer than 20 minutes, and then then it's a good idea to have lockets with you that also ingest sync. Then there is a nice little feature that we have a little showcase later. Actually, our devices are the only devices that can kind of transceive timecode. So they can, you can externally feed timecode into that, and then this device broadcasts it to the other lockets on set, which is helpful for some applications, as I will show you in one of our demos later. Then there is another little feature that you can kind of, for setting it up, you can just plug it to your sound recorder, for example, and it takes over frame rate and timecode from the sound recorder. This is also an application that can save time in some circumstances. Then what is also helpful for the rough set environment, it's a rock solid thing, you know, it's made in Germany, it's aluminum, you can jump on it, you can throw it away, and it will last. It's no plastic, it's hard aluminum, and we will showcase this later as well. You can use the same device that you can hook on a camera for being a timecode generator to be this in the hand of a director, using it as a logger, like pressing green and bad button for good stuff and bad stuff. I will show you later how this will show up in post-production, but this is also a nice little time saver. Then, to finish this, just let me introduce to you the current Locket family. We have our Nano Locket. As said, this is the Nano Locket. It has no display, it is a little bit smaller, and it has just the timecode output. Just timecode, but it fits better on smaller cameras, for example. It's easier to build in rigs, so that's fine. Then we have our Locket. This is the classy one with a display, which is great because you can do changes right here on the display, as I showed you before. And it has the two outputs, one for timecode, one for sync signal. Then we have our Slate. Yeah, the Locket Slate. It's basically a Locket with a bigger display and the Slate. And well, one might ask, why does a Slate? Why do you even need a Slate? Because, I mean, once all camera devices or sound recorders are synced by timecode, you wouldn't need this clapper to align this in post-production. However, this is still used a lot for different reasons. The one reason is there's always the thing where the director says, I have a great idea, put this GoPro up there, and we have another camera running, and this of course has no time, so it's always a good backup. Or if something went wrong, if the camera person decides to rip off the Locket, okay, then it's a good idea to have this as a backup and stuff like that. And also there are different metadata written on there. So still, the Slate has its reason. And then there is a new product coming soon. You're one of the first audiences witnessing this great moment to really see the Locket Plus in action. The Locket Plus again is a Locket, but it has some nice extra features. For example, it has a visual interface. I will show you that later, what we can do with all of that. You can adjust timecode settings and stuff like that. There is an internal, if you attach an antenna here, there is also the possibility of do a full frequency scan of your set. This is nice for sound recordists if they want to show which frequencies are available for their transmitters. I mean, there are other tools doing frequency scans as well, but it's nice to have it like in one box, like integrated in here. Then there is the possibility of doing lens metadata processing. I will show you this later as well with a Cook lens. They have the newer versions of them. They have a little output for metadata, and actually the Locket Plus and its predecessor, the Master Locket Plus, they are the only devices that really can kind of frame by frame record and broadcast this lens metadata. This is interesting for VFX-heavy productions and virtual studio applications. I will talk about that later in the demo. And then another plus of the Lockit Plus is that it can act as a metadata hub. I will show you also later that the Lockit Plus has the ability to kind of broadcast technical clip metadata to our Lockit script app. This is a script supervising app also from us. We will use that in another demo after the break. You see the clips showing up there, which is a real time saver for the post-production again. So that was it. That was it for the theory part. I hope I hope you're still with me, because timecode. I mean, it can get complicated at some points, but once you do it right, you will really have a happy and confident post-production, and they will thank you on your knees if you do it right on the set, because it saves so much time in post-production. Any questions so far on the whole theory and science and magic of timecode? Yes, please.
Did I understand right that if you are using only timecode cable,
Yeah.
and then you press record on your camera,
Mm-hmm.
the camera will swallow a little bit of the timecode from the cable, and after that it will use its own internal.
That's exactly right. Only the first frame after you hit record, this frame will have the right timecode. From then on, the camera does its own thing. From then on, it runs on its internal processor. As said, I mean, if it's only a 5-minute clip, you won't recognize the difference. But if the clip is longer, there will be a drift. It will lose the timecode. Yeah.
But the sync with sync you can get rid of
Yes.
that,
With
then the sensor is on the same rhythm.
exactly. It's really hardly controlled, the sensor. The sensor runs at the speed the Lockit tells him. So only then you're really 100% sure that this thing works. Yeah. You had another question?
It's about the cables.
Right.
I've come across some bidirectional timecode cables.
Okay.
Why would they exist?
I can't recall. Well, actually, I mean, we do it unidirectional because we also have this workflow that you can kind of feed in the timecode to this, right? So as it's plugged right here, we tell this is the clock, and it clocks this. But in our TRX mode, for example, we want this to be the clock, clocking this, and this would be so. Basically, maybe there are bidirectional cables, but actually, I don't see the sense now. Yeah.
I have a question about the range, and especially if you are shooting let's say, a big concert,
Right.
concert hall setting, but there's probably 1,500, even more people having a lot of gear with them, phones and etc. So, have you tested the range? What would be as a safe?
The safe range is, if you have clear sight, it's 200 meters in rooms like 100 meters. But the good thing is it doesn't get disturbed by cell phones or Wi-Fi's and stuff like that, because it's really more like if some IoT stuff standard, really stable. You can't really transport a lot of data through ACN, but the timecode information is not a lot of data. So that's why it's so stable. Yeah. And yeah, if everyone has recognized, if you kind of want to connect to some thing via Wi-Fi or Bluetooth in a Wi-Fi heavy environment, there's always a problem. So that's why we decided to build an own stable network to make that running, right? Yeah. Yes?
You mentioned how if you had multiple Lockit systems and you decided one was going to be the master and you held down the button and it synced with the rest of the ones.
Mm-hmm.
Is there a possibility that if you did that on one production and then for some reason right next door to what you're using is another production
Yeah, yeah.
that's using Lockit, is that going to interfere with their time coding system and settle there?
Absolutely, it would do. It would do. That's why you can put our ACN to different channels. We have 18 channels available due to exactly that reason, because there was the possibility in studio environments where you have like next door there's another thing. So in this case, but you have to communicate then. If you know there are several sets with lockets, then you should communicate. And okay, Studio 1 goes on channel 23 and Studio 3 goes on channel 30 or whatever. Exactly. There is also a little. Sometimes there is an interference with the wireless focus control from ARRI, because they are doing their protocol on a similar wave frequency, but you always have to have the possibility to switch the ACN channel, and you're good to go. All right. So then you have the possibility to take a little break to get some fresh air or take some drink and stuff like that. And in a few minutes, we will prepare the first live demo for you. We will do we will set up an interview situation with several cameras, audio recorded separately. We will see what we have to do to get this running and how this then goes together in post-production. So thank you for the moment and see you in some minutes. Thank you.